All right, we need to refresh our memory about simulation. So doing simulation might be like this. New businesses have to have an idea of their risk reward starting out. If they can make it through the first couple of years, they have a very good chance of being successful. Suppose a particular business wants to estimate that knowing that a third of their sales calls will result in a sale, they want to know how likely would it be that they would have bad luck, which we tend to call random chance, described by standard deviation, but they would have bad luck and make less than 2 sales in their first 12 sales calls. So we'd like to get a feel for that. Now, after having studied binomial probabilities, we can find that exact probability by using that approach. Simulation's different. Simulation is just taking sample data and finding relative frequency. We're going to estimate a probability, so it's really more relative frequency. And to do that, we use a different situation than the one that we actually want to estimate, but both situations have to have the same P, the same probability of success, and we'll just use this, this situation to estimate the probability via simulation. So again, if we looked at actual probability, we could come up with our binomial probability formulas and binomial PDFs, and we would get a probability distribution like this, and we'd be able to find the probability that X is less than 2 just by adding these two probabilities together down here. I think you get close to like 5% or something. But if we were going to simulate, now we could do this. We need some situation, rather than sitting around and waiting for another sales call and actually experiencing in reality, hey, I have our first 12 sales calls, which could take a number of days or whatever. Let's do a different situation that has the same success rate. We could roll a die. A die has 6 outcomes. You could get a 1, 2, 3, 4, 5, 6, and we could stipulate that out of those 6 outcomes, we'd say, well, these two, if you roll a die and you get a 1 or a 2, that represents a sales call for which a sale was made. So every time we roll the die, that represents a sales call was made. And if that roll is a 1 or a 2, then that meant on that sales call, we actually closed a sale, we made a sale. So what we could do is we could keep rolling the die, and every time we roll the die, every time we rolled the die, we would keep track of how many of the times did we get a success, did we get a sale, and then we're going to roll it 12 times, and after 12 times we see how many times did we get a 1 or a 2. And maybe the first time we got 3 1s or 2s out of 12. That would correlate to saying, oh, we got 3 sales out of 12 sales calls. And we keep doing samples of size 12, simulations of size 12. Every time we're done with the 12 rolls, we go back and we consider how many of those times did we roll a 1 or a 2. And we can keep putting our data together until after a while we get a feel for how unusual or typical something was. Well, oftentimes in the world of AP Stat, they're going to have us use a random digits table. Not that it's the best way to do it, but it allows them to know for sure whether we know what we're talking about. So we would have to take a random digits table. We would say, okay, how are you going to simulate? Well, to match the 1/3 probability, we're only going to look at digits from 1 through 6. If we get a 1 or a 2, and I should say this, we're going to look at digits from 1 through 6. Each one is going to represent a sales call. So you have to state what these guys are going to represent. Then out of all those sales calls, if we get a 1 or a 2, this will be a sales call for which a sale was made. And then we're going to say, well, anything else, getting a 3 through 6, we would say that no sale was made. Then we say we're going to look at digits in the random digit table until we get the first 12 digits between 1 and 6. We will throw out any other digits, and then we will count the 1s and 2s and record how many of those we got. how many ones or twos? And then we will recognize that the ones or twos will stipulate that we got a sales call, and that's how we're going to simulate how many sales would we make out of 12 sales calls. So you set all that up, you describe what the digits represent, how you're going to sample, how many you're going to sample, and make sure you say what it is you're going to record, and then you do your simulations. So we look at our first digit, it's a 0, that didn't work for us. It's not in the interval from 1 through 6. Neither is this. So this officially would be our first sales call, and it happens to be a sale. So we're going to circle it. We're going to circle this one because that was a sales call. This wasn't a sales call. So we've had 2 sales calls so far. We've had 2 sales. This is a legitimate digit. It's in the interval, but that's no sale, no sale, no sale. Here's a sale, no sale, no sale. And now we have to stop and keep track. How far are we? We've had 1, 2, 3, 4, 5, 6, 7, 8 sales calls. We need, oh wow, look at me. That 8 doesn't count, sorry. That's too big, that's too big. There we go. Once we get to this 6, we've had 1, 2, 3, 4, 5, 6, 7, 8 numbers that are in this interval. So we've been on 8 sales calls, of which 3 so far have resulted in a sale. So we keep going until we get to 12 sales calls made. There's an 8, that's no good. It's not in the interval 1 through 6. That's not a sales call either. That's our 9th sales call, but no sale was made. Outside the interval, there's our 10th, 11th, and 12th sales calls. These were both resulting in a sale. This one does not, and we put a vertical segment to say we finally made it to 12. So we ended our first simulation of 12 trials. Out of those 12, we have 5 situations where we made a sale, 1, 2, 3, 4, 5. So we record that. So what we could do is start out a table down here, 1, 2, 3, 4, 5. We can say, oh, we have 5 sales, or 4, or 3, or 2, or 1. In this first simulation, we found that we ended up with 5 sales made out of the 12 sales calls. And oftentimes we'll be asked to do 3 simulations. So we will do the next one. And here's maybe a little quicker and more efficient way to do it. We need 12 digits that are all 1 through 6. So let's first go through and count where we go to. We have to start where we left off and ignore the ones that are outside of this interval of numbers and figure out where do we go to end our second simulation. So that's not a sales call. There's 1, 2, 3 digits in the right interval so far. 4, 5, 6, 7, not that one. 8, not that one. 9, 10, not that one, not that one. There's 11, there's 12. So we could end our second simulation of 12 sales calls right there. So then we go back through, and in that simulation of 12 sales calls, how many ended in a sale? Those would be the digits that are 1s or 2s. So we had 1, 2, 3, and then this one 4. So we made 4 sales in those 12 sales calls. So we would put an X above the 4. We need to show one more. So again, I think the most efficient way is to do what we just did. We start where we left off. Let's go 12 sales calls, count until we get to the 12th digit. That's from 1 through 6. So that's 1, that's no good, that's no good. 2, 3, 4, 5, 6, 7, that's no good. 8, 9, 10, that one's outside the interval. 11, that one's no good. 12. So right there, that's our third set of 12 sales calls. Now go back through and circle all the 1s and 2s in that interval of digits, because those represent that we made a sale. So once again, we get 5. So our first 3 simulations end up in getting 4, 5, and 5 sales calls out of 15. So we've marked up the random digits table appropriately. People can tell what we've done. And then we've recorded the variable of interest, which is how many sales did we make in the 12 sales calls. We described what the digits were, etc. Okay, so then what happens, typically the problem will go on to another part, and they'll say, All right, use the results from 100 simulations to estimate the likelihood of making less than 2 sales in 12 calls. So knowing that these were the results from 100 simulations, all of size 12, then the probability of getting less than 2 calls is just these 4 right here. So our probability is 4 out of 100. And I shouldn't say our probability, because that's not the exact true probability. This would be a relative frequency, because it came from sample data. In this case, it was simulated data. So that would be an estimate of a probability, so that's why we refer to it as relative frequency. So that is the best estimate of the likelihood that we get less than 2 sales, or less than 2 sales in 12 sales calls using simulation. Let's go to a slightly more elaborate problem. Let's suppose that normally only 14% of people who go on a diet keep the weight off for more than 2 months. In one town, a random sample of 14 people who had dieted found that 6 of them kept the weight off for more than 2 months. Suppose we went in and say, hey, what do you attribute it to? And the guy says, I don't know, I'm at a loss for words. And we just sat around and chewed the fat for a while. I said, maybe the other towns have too many people of British descent and they're afraid to lose pounds. I don't know. Anyways, but use the random digits table, that's the best I got. Use the random digits table to simulate, that's good stuff. The sample sizes of 14 from the population, then use the results shown to determine whether or not this one particular town might be keeping the weight off at a higher rate. If we recognize this, this is hypothesis testing, but done not through finding exact probabilities, but by finding an estimate of it through simulations, so using relative frequencies to estimate true probabilities. Okay, so here we go. What we're going to do is a similar thing. We're going to state that every 2 digits now, every 2 digits represents a dieter, and we need to represent a 15%, we say, no, it's 14, a 14% success rate. So starting, we need all 100 digits this time, 2-digit numbers, 10 digits times 10 digits, there's 100 possible 2-digit numbers. So we're going to go ahead and start with 00, and we're going to say that any 2-digit numbers, 00 through 13, that would be 14 out of the 100 2-digit numbers, so it matches the 14% rate. These are the people that kept the weight off 2 months later, and then all the other digits from 14 through 99, these are the people who did not keep the weight off. So we've said what every 2-digit number is. It is a dieter, and then of those dieters, these dieters kept the weight off, these didn't. So we're using a random digits table, and the likelihood of getting these 2-digit numbers matches the situation we're trying to simulate in the real world. Then remember, we're going to look at, what do we say? Pardon me, 14? 14 people. We're going to look at 14 people, because that was our situation, and we're going to see, hey, in a sample of 14, how often should we get 6 or more dieters that kept the weight off? So this time it works a little bit differently. We're going to say, okay, we need 14 people at 2 digits apiece. That's 28 2-digit numbers to constitute one sample of 14 people. So these are in groups of 5, so 5, 10, 15, 20, 25, 28 would be right there. Once we get to there, we have 28 digits at 2 digits per number, or 2 digits per dieter. That's 14 digits or dieters. So we would say we're going to look at 14 2-digit numbers, and then we're going to record. You're going to say what you're going to record. We're going to record the number of digits in here, because they're going to represent the people who kept the weight off. So those 2-digit numbers are people who kept the weight off, so that's what we're going to keep track of in a sample of 14, how many of them were able to keep the weight off. All right, so then we go back through and we say now, since we have where our sample will end, it's as simple as looking at 2 digits at a time, circle all the 2-digit numbers that are in this range. So there's 1, there's 2, there's 3, so we're off to a good start, but then 43, 23, 87, 68, there's 0, 5, 90, 22, 48, 42, 56, and 32. So I think we got it, I got it right, I hope. Out of the 14 dieters, 4 of them, 1, 2, 3, 4, were digits in this range. So 4 were people who kept the weight off. So again, we'd start just a little frequency table or frequency chart right here. And we would say, oh, okay, in our first simulation we had 4 people who kept the weight off. Now we're going to look at another sample of 14 people, so that's another 28 digits. We have to start where we left off, that's 2 digits. Plus 5 is 7, 12, 17, 22, 27, 28. There's where our next simulation ends. Now go back through, find all the 2-digit numbers in this range. 57, 39, 25, 00, 41, 19, 72, 76, 32, 51, 4, and where am I? Oh, down here, 45, 76, and 01. So there we go. So this time we had 3 two-digit numbers that represented dieters who kept the weight off. So we get on here, and we put an X above 3. Then we do one more, 4, 14, 24, and then we go to another. So I ran out of digits, but you get the idea. So we'd go to one more set of 28 digits and record how many people. Usually on an AP exam, you'll be asked to do your first 3 simulations. Then they would take you to something like this, and they would say, okay, these were the results of 35. So there were 35 simulations using a random digits table representing a group of 14 dieters, and these are the number of the dieters according to the simulation who kept the weight off. So we want to answer the question, which is this town, is their result behaving within the realm of likelihood like a town that is having 14% of their dieters keeping the weight off? So this is very much like a hypothesis test. What we learned from simulation is that these are the typical results that should be coming from this population. So don't think that these are samples that came from this town. So let's think this through. This is actually where this is the idea behind hypothesis testing. So let's think about this clearly, then we're done with this video. And it's this: when you simulate, you set the parameter at 14%. You made it so that success rate is 14%. And just like hypothesis testing then, these are the kinds of results you should get if the null is true. These are the kind of results you should get if this is accurate. If the people in this town just have a 14% success rate, and this group of people in your sample just happen to be really lucky or unusual, and we got 6 of them that were able to keep the weight off. So what we do now is we say, okay, using our simulation, where again, these results are what should happen. These are the kind of typical results when the true success rate is 14%. Now we step back and we say, well, you know, the one and only sample we took gave us a result right here at 6. So how unusual is this sample from this town coming from a population that really had a 14% success rate? And the answer is it's very unusual. How often did we see 6 or more people in a sample of 14 keeping the weight off? The answer, it only happens 1 out of 35 times. That's less than 3%. So, well, I don't know, what is it, 0.029, 0.028 or something like that. So basically we're saying, you know what, we got a result that doesn't happen very often due to chance, coming from a population with a 14% success rate. This isn't exactly our probability of that happening, it's our relative frequency, because we didn't do a formal hypothesis test and use probability theory. We did a simulation and we just said, hey, in our simulation 1 out of 35 samples got that kind of result. So it's an estimate of the probability. So it's relative frequency. But because our one sample did not behave like the kind of sample results you would expect coming out of a population with this success rate, then just like hypothesis testing, we're going to say We think this town that we're looking at is from some sort of a population where their success rate is higher, and that better explains why their sample result was so unusual. So the ideas behind simulation can be used anytime you need to estimate probability using a similar situation that will match the success rate with the situation we want to have simulated. So go back and look at this if you need to, but you can expect to do some sort of simulation on an AP exam.